right. Um, just making sure everything's working. I think it is. Fingers crossed. Gosh, streaming stressful times. Yeah, thanks for coming along. Thanks for watching. Um, so what we are going to cover tonight is Docker. Now, Docker is a really useful tool. I've used it quite a bit. I've used it kind of all over in previous jobs as well as my current job, and yeah, it's a tool that I'm starting to get to really using it more and more now, and it's a very versatile tool. So it's widely used. You've probably heard about it, containerization. So if you heard things like Kubernetes and that kind of thing, most probably Docker is involved. Now, Kubernetes uses containers. Doesn't have to necessarily be Docker, but Docker is by far the most popular container used with the likes of Kubernetes. And that's kind of where the whole development industry is going. It's like containers and spin up instances and that. It's pretty awesome stuff. It means that you can have scaling and all that wonderful stuff happening. And also means the whole DevOps type approach to things and that. So it's really useful tool. Now, it's great for that, but it's also great for other things. So one of the things it's also great for is like DevSecOps, security, and it can be really beneficial. So I'm actually going down this route now, where there's work that I'm doing that involves creating all these Docker containers and that, and I'll probably cover it in a bit, see how much time I have, where you start going down the route of pipelines, and it can be really interesting from like a DevSecOps approach, where you can really start integrating security with using Docker. So yeah, that's Docker, and this is why I highly recommend you have a look, because it's not just application security specific or application specific. You can start using these instances for just about anything that you need a system, a running system for. So, what is Docker, and what are containers? Probably gonna have people laughing and poking fun at me for this, but Docker is not a VM. VMs and containers are two different things. And this page here on Docker's website actually does a really good job of explaining what the difference is. Personally, I still kind of view Docker containers as VMs, but they're not. So the thing is, with Docker, it utilizes the way the kernel operates, and that's a whole nother thing, and that's really getting into the depth. But basically, a kernel is like the heart of a Unix-based operating system, and Docker can share that. So it will use the same kernel as whatever host system that it's operating on. And that makes things a lot more efficient from virtualization point of view. Whereas a VM, everything is self-contained in that VM. So you have a hypervisor essentially running on the operating system, acts as an interface between your infrastructure or your hardware and the actual thing that you're running, where Docker kind of uses the underlying operating system to do some of the stuff. So essentially you are using, when you're running some of the stuff in Docker, you are using the actual operating system that you running Docker on. Now, there's a whole pros and cons of that. So one of the cons is that it's using the underlying operating system, so there is a potential for instances to speak to one another. The way Linux does that is like namespaces and all of that kind of isolate these things, but there's still potential things. So if you get things like kernel exploits and that type of thing, where a VM will probably be more isolated, or just isolated to the VM. But you get the efficiency gains that you get from doing that versus a VM. So I think provide a good page here. Yeah, so the good diagrams here. So this is comparing the VMs and Docker. So as you can see here, this is kind of the difference. Sorry, my system is just running slowly with the, I think it's the 4K, it just doesn't like it. and the virtual machine is just not happy. But the point is, you have your kind of VMs operating here, and as I said, you have the hypervisor and then the infrastructure, and then with Docker, it uses kind of the underlying operating system to do all of its stuff. So that's that, and I'm going to kill that page because that page is killing my system. Right, so that's a high level what Docker is. It's a VM, but not a VM. I didn't say it's a VM. I'll probably be crucified for saying it, but you get the layout. Simplifying things. Really, if you're going to go down to the nitty gritty, yes, it's not a VM, but from a conceptual point of view, it kind of is a VM-ish type thing. So what does Docker really look like when you're actually using it? So what I have here is a Docker file. Now, everything that you do in Docker is generated from a Docker file. So with Docker, you have images, and images are the kind of copy or instructions for running that specific image or container. And then once the image is actually running, it then becomes a container. And these are, trying to think of the word, they don't last. So if they're volatile. So that means that if I run a container and I nuke it, start again, it's going to start from scratch. So anything that's changed in terms of that operating system and file structure of the running container is lost once you kill that instance. There's a caveat to that, so you can mount volumes, and volumes allow you to have a file on the host operating system mounted into the container, and then that way data is persisted. If you don't do that, everything's lost. So here is a Docker file, and as I said, you use a Docker file to basically build the image, and then you run that image to form the container. Pretty much 99% of the time, you're going to have a from. So this from tells the Docker where to pull this or base this image on. And unless you really go in low level, you will always have that from. So the from allows you to layer different images. So you can build a image on an image on an image. So in this case, we're just doing Nginx, but some are like Nginx, Python, or Django. So we use the Nginx as the base layer, then do some Django, and then you'll do your image on top of that. So you can have these images layered, which is kind of nice because you can have things like base layers and all sorts of wonderful things in terms of a hierarchy structure. So yeah, really interesting. And in terms of the what do you call it? The copy is, this is a command to copy files from whichever system you're building into the image. Now it will be baked into the image. So remember I said it's volatile because you are defining the image or actually be in the image itself. So if we run this now, this is a very simplistic example. Run this here. So what we're going to do is we're going to do a Docker build. So if we do a Docker build, so -t is a tag, and I'll come into a tag in a bit. So I already have one called Nginx, so I'll just call this Nginx stream. And then dot for the current directory. So where you're building it, which directory. And here you'll see it's actually going to pull this image, and by default it'll pull it from the Docker Hub repository. It's a public facing repository. And if we actually come into it here, so this is the actual image that we are downloading, or the product that we're downloading. And you'll see there's these different tags. So with Docker, as I mentioned, you have the tag. So tag is basically a way of versioning different images. It can be alphanumeric or just numeric like that. We can have just names. but there's also this latest tag, and latest is what Docker will attempt to get if you don't specify any version. So if you see here, I haven't specified any version, so that's the same as saying : latest. That's what Docker will default to if I didn't specify the version. If I wanted to specify an actual version, you put : and then the version. And you can also see all the tags here by just browsing this here. You also see a Docker pull. So Docker pull is allowing you to pull that image down. With Docker, it caches it locally. So if you do a Docker pull, it will pull it down. So instead of me doing this build, say I wanted to get it before I did the build, I could have done a Docker pull and it would have pulled it down. And then when around the build, it would have seen it here locally, and then away it goes. You can also do a Docker image ls, and this will list all your images. So as you can see here, I have the image Docker. So this is straight from Docker Hub. It's built 2 weeks ago. And then the one I just created called Nginx Stream. And yeah, what we can do is actually run it. So if we do Docker run, so -p is to expose a port. So you have a Docker running. Everything in Docker world is kind of done in its own private network. So you need to start exposing ports. So the way this does is kind of maps a external port. So what port you want to expose externally to the internal port. And then the tag. So this is whatever Nginx server that you want to run. So I had created stream and we run this. And there we go. Should be running. So if we now come here, go to localhost. Cached. Wait, why is that not working? Let me just clear my cache. Gotta love cache. Get rid of that. There we go. So that's just a simple HTML page that I had. Yep. Nothing fancy to it. But you can see like just how quickly I can have. If I already have the HTML, I spin that up, poof, done. It was 2 lines. Rather than going through the whole realm of setting up a VM and then installing it and so on and so forth. So you can see how you can really rapidly spin things up. So yeah, this was just a very basic example. As I said, you can have things like Django. So if we look for Django, so there we go. There's Django, and it's using here's an example of how you can actually use Django. And you would just copy this into your Docker file, build it, and then away you go. Obviously, you would need to have your app and then import it in. So that's a very basic one. What I'm going to show you here is a bit more advanced Docker file. So in this case, kill this. We have Ubuntu, so we want to import from Ubuntu, and we're actually going to specify the version 22.04. Env will set an environmental variable. So in this case, this is pretty much what you always want to do when you're using Debian-based instances and you use an apt. So it will basically do it so it's non-interactive, so it doesn't prompt you for any interaction when it's doing the apt commands. And then run is actually running a command in the Docker image when it's building it. So in this case, we're doing an apt update to update the apt cache, and then we're going to do our apt install. So this is all standard Debian Ubuntu stuff. And the nice thing about this is it's like pretty much every package that's available for Ubuntu will be available here. I think every package, in fact. So yeah, we're installing OpenJDK, the headless version, and Maven. And then the last thing you want to do is removing the thing. Yeah. Now, there's a reason why you want to run this all in one. There's a whole realm, and I'm not going to go into it too much depth now about Docker optimization. Basically, the way Docker works is layers. And I can show you that once I've actually built this. You'll see the different layers being built. But basically, each command is an individual layer. And each command, the changes that are associated with that command are stored within that layer. So any changes, be it adding or removing, can affect or add to that. And by that I mean, if we now have a command that's deleting a whole bunch of files, that will actually add to the size because it's actually going to make the change to the base image, for example. Because it's a command, it's changing the difference between the different layers and that. So that's why you want to try to combine everything into as few commands as possible, because then that way, especially with like apt, if I didn't do this and I did each one separately, it would the cache would be added, then we do the install, and then we will remove the cache. So the adding and removing the cache would actually be two additional things, whereas here we're adding and then removing at the same time and then just installing. So essentially it just becomes this that's added. I hope that makes sense. Probably the other things out there that can explain it better, but if anything you remember is the more commands you run, the bigger your image size is probably going to be. And it's just because it's got to track basically all the changes. And that's even going for deletes and that. So that's all right, so hopefully that's a bit better. Apologies, I am really having problems struggling with my box. I have no idea. The joys of streaming. I have absolutely no idea what's going on. I'll have to see what I can do about it. Man, so frustrating. Let me just recap quickly. So with Docker, you basically want to keep all your commands in as few commands as possible. So yeah, like every command that you run is going to be another layer, be it adding or deleting. And if you're deleting well, actually basically every command that you run is going to be another layer, and that's going to add to the size of the image. So that's why you want to keep things as little as possible. Whole wealth of information up there. So this here, it's going to now create the directory called POC, and then change into the directory POC. Copy is going to copy the POM file. So basically whatever files that you have on your build directory, and put them in the image. So pom.xml, and then also the source directory, put it in source. Then we're running Maven. With Maven, you want to download all the dependencies and bake them into the image. So it doesn't have to download them when you start it up. So it's just going to make it a bit more efficient. And then that way you can have it start up a lot quicker, as well as not having to download traffic all the time. And then the last one here, so there's kind of two ways about this. There's command, and then if you also have a look here, okay, that's not that one. I thought there was another one. There's, I think it's exec, E-X-E-C. I just want to see, exec. No, entry point, sorry. Entry point. So entry point, you can provide an executable. So this will probably be like a shell script that you want to run, or you can actually use command, and this will run a command when you start up the instance. If you don't specify this, it's not going to really do anything. So this is kind of the crux of a image. It needs a command in order for you to run and actually have it do something. Or an entry point. As I said, with like an entry point, you would typically have a shell script that would then execute whatever you needed to execute. But in this case, we're just having Maven run and run this. So if we now come to here and go CVE, so we're going to do a Maven, no, not a Maven, a Docker build, and we'll just call this POC. What's it? Not build. Build. All right. So there we go. So it's put in down here. And when I was talking about layers, you can see there's 9 layers in the base image of Ubuntu. Actually no, there's 9 layers in the script that we are doing. So each one of these here is a layer. So you can see that's a layer. Actually, that's interesting. I don't know why this has been treated as a separate layer. Oh no, that's right. The apt. So this here is layer 3, and it's going to be relatively small because it will have the cache, but then also delete the cache as part of that single layer. So it's not actually going to store any cache. Or you want to do that update and remove the cache in the same command. So build that. Hopefully it won't take too long. Downloading half the internet. Yeah, and if you have any questions, please just pop them in the chat. Take a bit. Okay, so hopefully this won't take too much longer, and then you can see all those. Actually, while that's going, if you want to use a tool, like I highly recommend using Visual Studio Code. It has amazing capabilities in terms of Docker. So if you come have a look here, it's got all this integration in Docker itself. So you can see things like what registries you're connected to. So as I mentioned, you've got Docker Hub as a public one, but then you can also have your own private internal registries as well. And there's a few of them. So like Sonatype has it. I think JFrog has the thing. There's an open source one called Harbor that's pretty popular. That's another one that you can create Docker repositories from. And yeah, there's a few of them out there. And then images is all the images that you have. So this will include any that you've pulled down, as well as any that you have built. And then you can also see the different tags associated with them. I don't think you can actually do anything further here, but you can do this inspect, which will give you a bunch of information about it. Yeah, I've never really used this too much, but it's there if you really wanted to go investigate that further. The real crux is probably when you have an image and you actually run it. So in this case, we're going to run this POC. So you can see the Nginx one, it stopped because it's not running anymore. And we're going to do a docker run. I don't need to expose a port because it's just local. And I'm going to do a difference here. So I'm going to do an I and a T instead of just the T. And I'll explain that now. And then POC. POC. So the reason why I did a I as well as the T is I is for interactive. So it's a way that will open the shell or whatever you're running. So in this case, it's looking for input and it will allow you to interact with that. If I didn't specify the I, I'm not going to do it because it's a pain. I can't get rid of this. It won't actually allow you to enter anything. So that I is important if you want to have some sort of interaction with it. The other nice thing that you can do with Docker and Visual Studio Code is you can now actually attach a shell because it's essentially running as a instance. You can actually have a shell to it. So in this case, I actually have a shell to this Docker container. And I'm trying to, so if I do like a, I think RP address, oh, it doesn't have that. I forgot what the command is to install RP, what package you need, but you can, like, this is really useful if you want to debug things. So I think you can do apt install net tools, or is it utils? I always get this mixed up. I always forget this. So get an apt update. No, net utils. I forgot. Tools. There we go. So now I install that, and then I can do like ifconfig. And you can see that the IP address is not with Docker, the kind of standard default one is 172.17. That's the subnet. Oh, .0 it is 1/256. I don't know, but subnet, my network is not great, but that's kind of the default subnet that you are on. And yeah. Now, if I kill this container, anything that I have done locally on this container, so anything I've done in the shell, will be nuked. And if I start it up again, it will be as if I've never touched it. So that's kind of a good thing. It allows you to have like really consistent states. If you do need to store anything and persist anything, as I mentioned, there is the volume. So you can mount a volume, and that way things will be written to a more persistent state, like a file system on the host system. So yeah, that's running there, and as this is a full container, so instance of Ubuntu, so you can do anything that you would normally do in the likes of Ubuntu. The other common one or container distro that's used in Docker world is called Alpine. It's a very stripped out version of Linux. My word is just be very cautious about using that. The reason why I say that is, as I said, it's very stripped out, so you might find it very restrictive, and sometimes it's an absolute pain to get things working. And you're talking maybe saving 10 megabytes, where it's not really worth it. I've literally taken an Ubuntu, I've taken an Alpine, and I've tried to do the same thing between the two. And there was no difference, absolutely no difference in terms of the performance of the two. Maybe a slight difference in the image size, and really the space these days is not that expensive. It's going to save you a whole lot of grief if you go with something like Ubuntu, You have all the packages there and all of that. If you really need more like low level performance, and it's, as I said, like I didn't even notice the performance difference. But if you really need that low level stuff, Alpine is the other one, but be aware that you're probably going to hit issues. The Ubuntu itself is like 30 megs, the entire image instance size. So even that standard is pretty low. And I think you can see that. So if we terminate that there, so I've terminated that. I think it's Docker image ls. I think it gives you a here. So yeah, there's a size there. So if we have a look at like Ubuntu, okay, well I lied. It's a little bit bigger than 30 megs. I'm sure it used to be 30 megs. Maybe there's a really stripped down one, but anyway, it's not that big. I mean, 70 megs is not that big these days. But yeah, you can get the different file sizes there. So yeah, the other cool thing I can show you in here is, let's run this again. This is why using something like Visual Studio Code is so really useful. Come here, you can see these files. So you can actually view the file system of this container itself, rather than actually having to go into the container via bash or something like that. So where's... so if I go like, I don't know, hosts, you can open that and you can actually modify it. So let's do like, I don't know, 172.0.0.3. I'm just making this up. Just so you see me. We'll just call this test. Save that. Okay. Maybe there's something with file system or permissions or something like that. But the point is you can save it, and it will save to the file system. Now, you might find that you don't actually have Visual Studio Code or something like that, and you need to get access to the instance still. So you can do something like this. You can do a docker exec. So docker exec will actually execute a command. So in this case, again, the famous RT, the one thing is we need to get the container name. So we want to do container this time. So this is getting a list of all the containers. You can use names. So if you don't specify the -- name tag or argument when running a Docker container, it will generate these cool little names themselves. So we can do docker exec -it. In this case, I'm just going to use a container ID. Did I copy that? I'm going to paste that there. And you specify the command that you want to run. So in this case, we want to do bin sh. And there we go. We got sh on the container, and you can do all sorts of things that way. As I mentioned, you can also specify the image name. So what's it? Bold Kepler. And there we go. So that's a way that you can actually access a container, or even just run a one-off command against a running container. That can be helpful, especially if you don't have something like this here. Yeah, so that's pretty much it there. It's there. If you wanted to have a look at the other commands, so if you go to what's it, docker commands. There's a pretty Docker's documentation is actually pretty good. Just trying to find it. They have a whole bunch of commands that you can actually run. I'm just trying to find it. Pretty sure it was here. Let's see if I can find it. Oh, jeez. Docker copy reference. There we go. Docker file reference. There we go. So this has all the commands that you can run, gives you a whole bunch of information, gives you examples and all that. So if you are looking for something to run, I would highly recommend bookmarking this, coming to this. There's things like labels and all sorts of things that you can do, like exposing the ports. Yeah, just a bunch of things. So have a look at it. I've not used all of them. By far, the most common ones that you are going to use are pretty much the ones in here. So basically, env run. There's also user, so you can switch users, copy, and command or exec. Those are pretty much the most common ones that you're going to see. Let's kill everything else, and that's Docker itself. Now, there is another thing that I want to show. Is called Docker Compose. It's all very well doing these Docker images on their own, but you can now start have these different Docker images starting to interact with one another. And this is kind of what Kubernetes does. But you typically probably some cases don't want to spin up a whole Kubernetes cluster, and it might be a bit cumbersome. This is where something like Docker Compose can really, really come in handy. Kind of like a poor man's way of doing Kubernetes. And it allows you to define different containers and attributes associated with those containers, and they can then start talking to one another. So in this case, we have this Docker Compose for OWASP dependency track. And it's defined by docker-compose, and there's a utility called docker-compose, surprise. And you can then build these compose files and run them. And it can actually, it will download the Docker image and then run it with the different options that you have. In this case, we have the image dependency track server. We call it the service dtrack API server. So this will be running as that service in the Docker container or Docker Compose landscape. So when you run this, you'll see the different containers running. And then you can have different things like resources, what ports, what volumes. So this is where I mentioned the volumes before. So this will have a dependency track volume stored, persisted within Docker on the host system. So anything written to /data will then be persisted. So if I start and stop it, then this is the place where you want to store like database files and that kind of thing. And then there's this front end image itself, and that depends on the service dtrack API server. So you can have these different services speaking to one another, and then you have different things there as well. So if we start this, so let's go into dtrack. All right. And how you do this is just Docker Compose, Compose up, and this will bring that up. Now you can do a Docker build, which if there's any Docker files, it will build them as well. But in this case, we don't have any Docker files. We're just doing it. It's running the Docker Compose. So here you'll see it's downloading the different Docker images to run. Just download that one. And then it's going off and doing its thing. So you'll immediately see there's this dtrack section here, which is defined. Actually, don't know where that's defined. Okay. Don't know. Oh, it's probably the directory. And And then you have your containers running in there. And we have the two containers talking now available. They're not necessarily talking to one another, I think. Because it's all going through the browser, but they can actually talk to one another. So if I come here now and you go to, should hopefully work. Show it's not cached. So there we go. There's it up and running. And yeah, we have the front end, which is this here. And if you don't believe me, there should also be a back end. If we come to the network and I try log in. There we go. So you see that's on 8081, which is different from the front end. So you can actually see them running. And if we come here, we do a net. So we can do a Docker container ls. See the Docker containers running, 2 of them there. And you can also do a Docker network. Can spell ls. So we can see the network associated with that service. And you probably can do a lot more if you go into the commands itself. But yeah, this is going to be really helpful is when you want to start building like little mini clusters and have services running. So in this case, like dependency track, you have things like Defect Dojo. I'll see if I can go. Let me see if OWASP Juice Shop. Come to OWASP Juice Shop. Pretty sure they have a Docker image as well. I don't know if this is just built into one. I think it is one, but let's just see. But there is one OWASP defect. Trying to find the documentation for this. Oh. Docs. They do have one here in terms of Docker. So yeah, here's a Docker Compose. They kind of have a script that does this all for you, but when I'm trying to see, oh my gosh, this is so slow, is I'm just trying to see if they actually have a Docker Compose script that actually shows you the different components. I think it is. Over here somewhere. That's Docker file. Might actually be in Docker. Nope. Here it is. Let's just see. I think tried this one, yeah. So yeah, this is what I'm trying to get to. So here you can actually define different things and have different entry points and different services and have different services rely on other services, and it can get quite complicated. The point is, as I was trying to make here, is you can have things like MySQL. So there are MySQL, there are Postgres Docker images. I don't know if there's MongoDB. I think there is. But basically, just go to Docker Hub, search, see if there's a Docker image there. and then you can tie them together nicely with something like Docker Compose to really spin up a little environment, an instance. And this is kind of the way that I run things now. In the past, you kind of have to download the software, manually configure and that, whereas now you just get something like Docker Compose, put everything in there. Half the time it's there ready for you. Run a command against the Docker Compose file and you're done. It's the instance up and running. And the other great thing about this is anytime there's an update, you just change the version number typically, and away you go, and it'll pull down the new version and you get the new version installed without the hassle of going through all the configuration and all that again. So this is why like Docker is a really, 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 really useful tool, a really powerful tool, because you can start building all sorts of things. So for example, at the moment, one of the things I'm working on is trying to build a Docker tool that's going to then use pipelines to build into our CI/CD that can then run a scan for our dependencies and upload that to a dependency track instance. And this is the notion of where pipelines are. Now, I don't have any examples offhand. I'll probably try to do another session on this. But if you have a look, there's these like actions. And basically it means like when you do a commit, it will actually run a job. And there's pretty much on any modern CI/CD, there's a notion of a pipeline. GitHub, they're called GitHub Actions. GitLab, they're called CI/CD. Jenkins, they're called Jenkins Pipelines or Jenkins Blue. And you can have these little Docker containers doing all the work. And it means that you have the build happening in an isolated, self-contained instance thing. And it will do it, spin it up, build it, spin it down. And the nice thing about that is when you spin it up, you know that each time it's going to do so, it's going to be in the exact same state. And you can version control these things. You can have checked in to like Git and all of that. So that's why it's going to be a really, really, really useful tool. Not just for like DevSecOps and that, but Jesus. There we go. Anyone know of a place where I can throw my laptop? It's so annoying. I have no idea what is going on. It's so frustrating. I have to have a look. I don't know what I'm going to do. Anyway, where was I? Yeah, so build pipelines, you can do a whole bunch with them. You can like just really your imagination. And the nice thing is it's like pure DevOps type thing. So you code it all, version control it, check into Git. So if anything does blow up, you can just rebuild it again. And yeah, you can have everything automated. It's just a really, really, really versatile tool. The other thing is that is going to be really interesting. I haven't done it yet, and I really want to start looking at this, is when there are vulnerabilities for different things, different software. So like Apache has quite a few, or even let's say, for example, there was a vulnerability in Jenkins. If we come here, Jenkins, and yeah, we oh, that's been deprecated. But say there was an instance of this, like say maybe there was a vulnerability in 2.60.3. Now I could go off and download it and manually set it up, or I just run a Docker image and then I can play and tinker with it. So that's really a powerful tool when we want to even do things like research. Rather than having to go through the whole process of setting it up and all of that, we just put it down and run it. Dead simple. So we're not spending time on setting things up. We can rather spend time on actually researching and doing things. So that's another really powerful use of Docker. As I said, I got to start using it that way. I've always planned to use it, but I've never got around to it. And maybe I can actually run my streams via Docker one day. I've put up with all this stuff, the technical guff that I got to deal with. But anyway, so yeah, that's Docker. Really, really versatile, really, really useful, super powerful, and yeah, hopefully you have all found this useful. Apologies about the audio issues. I don't know what's going on. If any of you do have ideas, please let me know. I would love to fix it because it's driving me up the wall and causing me issues now. And yeah, maybe I need a new system. But yeah, hopefully this is useful. If you need to know anything more, I'm by no means a Docker expert. I've been using it a fair bit of chunk, but I'm by far no Docker expert. I know enough to do things that I need to do. But at least this provide you some sort of entry point, hopefully. Yeah, go off, build things, break things, have fun. And yeah, I'll catch you later. Have a good one. Bye.
Swear I won't forget this, why do I regret this? In my mind reckless, thoughts are feeling endless. Sitting up I'm breathless, anxiety's infectious. I feel so defenseless, betrayed and embarrassed. I hate being open, I hate being broken. I feel like an ocean filled up with emotion. Anger ain't a potion, rub it on like lotion. I can feel it soaking, reopen, the scars have awoken. I can't move on till I let go. I feel so lost, never at home. Need to be strong.